Now we are going to discuss about one more force, that is tension. What is tension? See, if suppose I hang a body, say of mass m, say it is 10 kg body. This is the string. See, if you don't hang anything, there is no tension. Tension is zero. Here I assume that string to be massless. When there is no mass, when there is no body hang to it, and assume the string to have zero mass, then your tension is zero here. String is loose. It's not tight, it's loose. The moment you hang this body of mass 10 kg, immediately a tension gets produced. So what's tension actually? What's tension? Tension arises out of the elastic property. Tension is, the origin of tension lies in elastic property of the material. When you hang this mass of 10 kg, it tries to break the material of the tension apart. This string consists of the molecules. Inside the string you have the molecules, right? So it tries to stretch this. It tries to stretch this string. When you have this 10 kg, you have 10 G force acting on the string. This 10 G force try to stretch the matter, right? The moment you stretch the matter, you have a kind of inherent force getting generated which prevent this matter from falling apart. You have an inherent force which is getting generated which tries to oppose this force, which tries to prevent the matter of which the string consists of from falling apart. Like suppose you are a student, right? In usual life you are not tense, but suppose I announce the exam, say you have the exam day after tomorrow of mechanics. So what I have done is, by announcing this exam, I have applied a force on you. You got stressed. The moment you get stressed, you develop a tension. That tension, you develop a tension in order to prevent yourself from falling apart under the force which I have exerted you in the form of announcing exam. Like during the exam you get more tensed. Why you get more tense? Because exam stretches you. And you develop a tension to oppose those forces which act on you in the form of exam. You get tensed. The more force, the more important your exam is, the more tense you are. The more heavy weight you apply over here. If I apply say 100 kg, the tension developed is more because the force which I am applying on the string is higher. So more tension is required to prevent the body from falling apart, right? If I announce the final exam, say you have the exam, a very important exam, day after tomorrow, that's going to decide your whole life. In that case, you become more tensed because the force being exerted on you is very high, and you have to oppose those forces. You have to keep yourself together. You don't want to fall apart. You don't want to get affected by that force. So you develop a tension against that force. You develop a tension and keep yourself cool and calm. You try to prevent yourself from falling apart as a result of that force acting on you. But then there is a maximum value of the mass which I can hang in a string. I can't keep on increasing this mass. A time will come when the tension will reach the maximum value. Right? See, for every rope you define some body, you define some mass, like you say from this string you can't hang the maximum body, the maximum mass which can be hanged is 100 kg. It means what? See, every rope has got some kind of value. Like you are told that you don't hang, for every rope there will exist some value Like if you hang mass of more than that value, the string will break. Suppose I have this string and I tell you that you can at max hang 100 kg. Means what? It can increase its tension value till 100 G. If you hang a mass more than 100 kg, suppose I hang 110 kg, in that case the tension can go maximum to 100 G, and in that case if you hang more than 100 kg, this string is going to break. This string is going to break. In case of our life also, we get tensed as you are subjected to some kind of stress. You get tensed, right? You have this exam, that exam, but then a time comes when you give up. You break, right? You give up. Till you are trying to maintain yourself, you are tense. Suppose I have an exam and I know that I have certainly failed. I am not prepared. I won't get tense. I'll just break, right? Every person has capacity to get tense. To what extent I can get tense? Like to what extent I can manage myself. If I am subjected to the force more than what I can manage, I'll give up. I won't get tensed. I'll give up. I'll break basically. The person breaks. Person give up. You don't get tensed. You just leave everything on destiny. That's the breaking value. You can't subject any person to a very high level of stress. There is a level of stress at which it breaks, and you can't apply more force. That is not going to increase the tension. In fact, tension will become zero in fact, right? The same thing happens with the string also. If you hang more than its designated value, if you hang it 110 kg and the string has capacity to increase tension only till 100 G, in that case the string will break at some point, right? And tension will become zero. This mass will fall apart, right? So that's tension basically. Tension has got an origin in the intermolecular forces. When we apply a force, you try to stretch the molecules, you try to stretch the distance between the molecules, as a result of which a restoring tendency gets generated inside the string. As a result of which, when you try to stretch it, the molecules get stretched, the distance between the molecules which form this matter start increasing. So there is a restoring force generated, and that restoring force generates this tension. So tension is of electromagnetic origin. Tension is a property of matter. Tension is the property of matter. But for mechanics, I should tell you one thing. If you hang this body and you apply the free body diagram, you remember one very simple thing, that one of the forces is going to be mg, and tension always, you apply this tension T always in the direction of string. Tension always acts in the direction of string. In whichever direction you find the string, you apply this tension T, right? I'll give you one question. Let me give you one question on this tension. Suppose you have, say, I give you this question. Suppose we have the pulley and I hang, say, 10 kg and the string passes on this pulley, and on this side say you have 5 kg, and I want you to calculate what is the acceleration. What is the acceleration? It is a light frictionless pulley. It is light frictionless pulley. You have a light frictionless pulley, and you have to calculate what is the tension developed in the string and what is the acceleration. We also calculate what is going to be the tension, right? So you draw the free body diagram. You have this 5 kg, you have this 10 kg, right? So one force is going to be 10 G, and tension always act in the direction of string. You have the string in upward direction, so T will act in upward direction. You have tension T in upward direction since the string lies in upward direction. You have 5G, and let's suppose the acceleration is A. So apply Newton's laws. This 10 kg is interacting with the string, so you have the tension T it interact with the ground, so you have the gravitational force 10G. Here 5 kg interact with the ground, so you have 5G. Interact with the earth basically. It interact with the string, so you have a tension T over here. Tension always act in direction of string. For 10 kg string lies in upward direction, so you have tension in upward direction. For 5 kg string lies in upward direction, so you have tension T in upward direction. So if this body moves by a distance of x, this body will go up by a distance of x. So the acceleration, if 10 kg is moving downward with acceleration a, 5 kg is also going to move upward with acceleration a, right? If the velocity is v, the velocity will be v in upward direction. If acceleration is a in downward direction, 5 kg is going to accelerate in upward direction with a. Alright. Now, if I apply Newton's law, Newton's second law, you have a net acceleration a in downward direction. So net force in downward direction is going to be 10g minus t equals to 10a. Now, you have the acceleration a in upward direction over here. So what is net force in upward direction? T minus 5g equals to 5a. So this is 1, this is 2. Alright. So if I add 1 and 2, what do you get? You get 5g equals to 15a. So a will be g by 3. And tension is going to be 10g minus 10a. That is 10g minus 10g by 3 is 20g by 3. That's going to be the tension. That's going to be the tension. Right? So tension, you only apply tension in the direction of string. Now if suppose I have one more block over here, say it is 3 kg. So you have 3 kg over here. Then what will be the tension in this string and what will be the tension in this string? What will be the tension in this string now? So you have now 2 string. I love this. So I have one more body now. That is, you have a body of 3 kg. It is interacting with the earth. So you have 3g. And now 3 kg is also interacting with this string. This string is different. So I will take the tension at T dash. String lies in upward direction. So I will take T dash. Now 5 kg also interact with this string. And this string for 5 kg mass is lying in downward direction. So your T dash will also act in downward direction. Your T dash is, you have the string, one string in upward direction. So you apply T in upward direction. You have this string in downward direction. So you apply this T dash on 5 kg in downward direction. For 5 kg you have one string in downward direction as well. So you apply this T dash in downward direction. And now suppose your acceleration is A, 10 kg mass is accelerating with A in downward direction. So of course 5 kg and 3 kg is going to accelerate with A in upward direction. And I'll write the free body, I've drawn the free body diagram. Now I'll apply the Newton's second law. You have the net acceleration in downward direction. So net force will also act in downward direction. So the net force in downward direction is going to be 10g minus t equals to 10a. And this is going to be t minus t dash minus 5g is 5a. This is t dash minus 3g is 3a. If I call it equation 1, equation 2 and equation 3, then this is going to be, if I add all these, I'll be getting 10g, 5g, this is 2g equals to, so A is g by 9, okay, and t comes out to be 10g minus 10g by 9, that comes out to be 80g by 9. Alright, and here if I put t dash is 3g plus 3a, that is 3g and g by 9, so 3 will come out, so that is 10g by 3, that is your t dash. Alright, that's your t dash, that's your t dash. This is the tension, t and t dash. In this way you can calculate this t and t dash. So that's about tension. We'll make use of all these forces in the coming questions, right? So that's about tension.